I try not to have too much dead space, but it happens. So, but we're talking about here chapter 12, and we're talking about sequences and series. So we talked a little bit about what a sequence is last class, right? At least I gave you what a sequence was. I gave you the Fibonacci sequence, right? So they'll use a notation like A sub n in a bracket, right? In the curly bracket, that stands for a set. Equals 1, comma 1, comma 2, comma 3, comma 5, comma dot dot dot, right? So they'll write out term by term for the Fibonacci sequence, right? This is our Fibonacci sequence. Fibonacci. And so coming up with an nth term, so this n is a subscript for the index, right? The first term, the second term, the third term, and we're always kind of thinking about it that way. We've seen subscripts before, right? Where have we seen a subscript in math before?
Bases.
What's that, Ryan?
Bases.
A basis?
With bases and powers.
Yes, you're actually, yes. I mean, that's a little bit. Base. Base, like base 10, like log base 10. Are you saying log base e?
Yeah.
Yes, absolutely. And slope, right? Right. What have we seen? M equals y sub 2 minus y sub 1 over x sub 2 minus. Right. So it's just saying the first y value, the second y value, the first x value, the second x value. Right. That's kind of the thing. So if I see this, they might ask me, what's the first term? Right. So the first term is 1. What's the second term? A sub 2. So that subscript is just saying what term number am I at? A sub 2 is 1. What's a sub 3? 2. Right? This one is very hard to write in nth term, but in this case we can write it recursively. Recursively meaning it will refer to the previous terms. So a sub n minus 1 plus a sub n minus 2. Now that's pretty weird. If I look at that and I go, oh, I don't know what the hell's going on. But the idea is to fill in values of n. So for example, if I filled in a sub 5, this one would be a sub 5 minus 1 plus a sub 5 minus 2. And when you're doing things in this type of problem, it's good to do this as baby steps. So you can see I'm actually just replacing the n. Right? And then simplify it. So a sub 5 is actually a sub 4 plus a sub 3. And now it makes sense. Right? I took two previous terms and added them up. Right? So what is a sub 5, by the way? 1, 2, 3, 4, 5. Right? We know a sub 5 is 3 plus 2, which is 5. Right? It's the two previous terms added up. Right? Is that making sense at all, this subscript idea? Nth term, first term, second term, nth term, right? Thank you, Oscar. Oscar just gave me a thumbs up. So yeah, so just looking out into the classroom and seeing how many scared faces I see. So we're doing okay here. Everyone's following me, right? So this is the first aspect of possibly writing out terms of a sequence, right? And a sequence is simply a list of numbers for us, right? So, for example, we might have something like so just as another example here, a sub n, right? And you'll see all this kind of notation is the set of let's say n plus 1 over n squared, right? So they might give me the nth term, or I might have to come up with the nth term, right? So this is the first little game we're going to play, types of problems. So if I give you a formula for my sequence, can you write out some terms for me, right? And so the idea here is I write out a sub 1. And when I do that, I'm going to actually write 1 plus 1 over 1 squared. I'm not trying to do the math while I'm plugging in, right? Okay, but now I get it. It's 1 over 2. Oh, sorry, it's 2 over 1, and that's just plain old 2, right? Let's see if I can get a sub 2. A sub 2. Now each n, right? Am I talking about my next index, the second index, right? I'm putting in a 2. So 2 plus 1 over 2 squared. So that's 3 over 4, right? I don't know if I can kind of see a pattern here, right? Can I kind of see the pattern here that I don't have to keep plugging into the sequence? Can I just get the next term right away? Once I start writing them out, sometimes I can see a pattern, and us humans are pretty good at seeing the pattern. I got a 2 over 1, I have a 3 over 4. Next one's going to be 4 over, remember I'm doing what to that downstairs? I'm squaring it. Yeah, so I can now see my next denominator is going to be 16. I don't have to, once I see a pattern in the formula when I plug in, real simple like, I could probably just jump to the next term as I do them, right? Is that making sense at all? And so certainly I could write out all the terms now: 2, 3/4, 4/9, 5/16, right? 6/25. Yes, you with me? Nice. So that's one of the things I should be able to do, write out terms of a sequence, right? They might give me terms and ask for an nth term. That's the interesting problem. So we're saying find an nth term. So I'm going to give you a bunch of terms. So for example, 1 over 2, 2 over 3, 3 over 4. Can you tell me what comes next? Very easy, right? What comes next?
5 over 4.
5 over
4.
So 4 over 5, right? 4 over 5. Yep. So you can see my old denominator becomes my new numerator, right? So the next one's going to be 5 over 6, etc. But how can I describe this in general as n? So remember, this is n equals 1. This is n equals 2. This is n equals 3. This is n equals 4. This is n equals 5. What do you think here? Well, do you recognize?
N over n plus 1.
Yes, it's it. A sub n is n over n plus 1. So usually you could look at things, right? Sometimes you can just look at things and you might notice, right? Now I'm going to show you another way of getting it without just kind of guessing and checking. But for a bunch of them, you really just simply need to just look for the pattern there related to n, right? So finding that is, there's a couple of interesting ones. So let's just take the odd numbers, right? So this is another one, and I'll see if I can. This one I might not be able to just come up with a formula, but I'm talking about 1, 3, 5, 7, right? 9, etc. So we're talking about the odd numbers, right? Can I come up with an nth term for that? Well, when the sequence is arithmetic, and arithmetic meaning I'm adding the same number every time, and you can see here, what am I adding? From 1 to 3, I added 2, right? From 3 to 5, I've added 2. From 5 to 7, I've added 2. So this is arithmetic, and really what I'm looking for is some kind of linear combination between n and a sub n. So I'm looking at n and a sub n. How are we doing here? Are you following me? Everybody comfortable with what's going on here? I got a couple of nods. Elise, yes. Cindy, yes. Wilder, thumbs up. Aiden, Oscar, great. Remember, I am your Uber driver. You're paying me to get somewhere, right? And if I'm driving too fast, don't wait till I drop you off and give me a bad rating. Tell me to slow down, and then later give me the bad rating. So, but n is, I'm always starting at 1, right? And then a sub n are my terms. So my first term was 1, and then the second term was 3, 5, 7, 9, right? Comfortable here? We're comfortable? So you've done this before. This is an mx plus b problem, right? So I can get slope from what, 3 minus 1 over 1, oh, sorry, yeah, 3 minus 1 over 2 minus 1, right? I got lost there for a second. So 2 over 1 or 2, so my slope is 2, right? And how do I get my b value? Does anybody remember? Can you figure out the b value there pretty quickly? So I'm going from 9 to 7, 7 to 5, 5 to 3, 3 to 1. I'm going from 1 to what? Negative 1, nice. Was that Manish? Elise, right? Sorry. Yeah, I saw. I heard your voice, but I saw Manish had the yellow light on, so just got confused. Nice, negative 1, right? So my a sub n then is coming from 2n minus 1, and there it is. A sub n is 2n minus 1. Should I write it in the curly brackets or not? If just do what WebAssign wants. If WebAssign starts with curly brackets, keep it in curly brackets, right? I tend to write it more like this than the book. And the book talks to these things about functions, and whereas I talk to them as subscripts. So they'll say a sub 1, they'll say a sub 1 is 1, a of 2 is 3. And I'm writing it as a sub 1 is 1 and a sub 2 is 3, right? I'm using the subscript notation. So don't be afraid when the book is writing it a different way than I am. It means the same thing. And we're really talking about these indexing, right? The first point, the second point, the third point, the first term, the second term, the third term. So that one's not as easy to see, right? That one's not as easy to see the nth term, but it's pretty easy to find the nth term if it's arithmetic, okay? And so really what we're dealing with in our course and in Calc 1 are arithmetic sequences. In Calc 2, we'll start talking about geometric series. And you'll learn that piece just in time. It's called just in time. We're not, pre-calculus is usually has concepts from Calc 1, Calc 2, Calc 3. And what I'm doing this semester is stripping it from all of the Calc 2 material and Calc 3 material. And so we're trying to improve your grades in pre-cal by giving you less material, and improve your grades in Calc 1 by, really focusing in on the concepts that you'll need in Calc 1. So, you remember my goal. My goal is for all of us to pass with A's and B's. That's what I would like to happen this semester. So I can either see the nth term or I can figure out the nth term, right? And so let's do another one, maybe where I can just see it, okay? And it's definitely it's a little strange, but let's see. So I've got 0. Don't tell me. I'm thinking of this in my head, and I shouldn't be doing that. I should write it down secretly over here. Okay, here we go. 3 over 4, 8 over 9, 15 over 16. So I think on this one, it's one that we would be able to figure out. So again, but I want to relate it to n, right? This is n equals 1, this is n equals 2, this is n equals 3, this is n equals 4, right? You with me on that? I'm trying to find the nth term here. I kind of see it. I don't see it in the first term, but I can kind of see something in the second term, and the third term, and the fourth term. Does anybody else see it?
Yes, Professor.
Nice. Ryan thinks he's got it. Anyone else see it? Something related to n in my fraction. Can you see something related to n in my fraction? No one? No one else? Go ahead, Ryan. Let them know. What do you see? What's related to in the second term? Where do you see n there?
Let's see it below.
The denominator.
The denominator.
Yes. What am I doing with n for the denominator?
You squared it.
Exactly.
On the numerator.
Exactly. So a sub n looks like n squared downstairs, right? But it's always one less upstairs, right? So this one must be 0 over 1. That would make sense, right? So 1 squared is 1. But then how do I get to 0? I'm going to subtract to get to 0, exactly. So it's n squared minus 1 there. It's not, it takes some practice, but you're looking for special things. You're looking for, right? So there's some special ones we want to look out for. But do we agree at least that this works? N squared minus 1 all over n squared, right? So you can clearly see the downstairs 1 squared, 2 squared, 3 squared, 4 squared, and the upstairs is 1 less than that. So there are a few that are special, right? So we definitely want to write a few of these down. So what do we had? We had odd numbers, right? So special nth terms, right? We had the odd numbers was a sub n was 2n minus 1, right? What about evens? What would the evens be? Just 2n, right? So when I plug in 1, I get 2. When I plug in 2, I get 4, right? That making sense? We just saw n squareds, right? The squares. So a sub n is just n squared, right? 1, 4, 9, 16. So things like this. We're looking for little patterns like this. How about the on-off switch? This one's a little bit weird. On-off is this guy, -1, +1, -1, +1, ... right? So that's a special one to look out for. So I know, right, that I can get a negative if I have an odd factor of negatives, right? If I have 1 negative or 3 negatives and I multiply them together, 7 negatives, I'm always going to get a negative. And I'm going to get a positive if I have an even factor, right? Does that make sense? So this one, a sub n, is -1 to the n, right? So watch when I write that one out here. What do I get? -1 to the 1, comma, -1 to the 2, comma, -1 to the 3, comma, ... right? You see what's going on? So when I have odds, when I have odd powers, I'm going to keep the negative, and when I have evens, it's going to change it to positive, right? Does that make sense? So -1, comma, +1, comma, -1, comma, ... Are you with me there? So these are a few of the special ones. Elise, yes?
Yeah.
Factorial is a special one. factorial you might not have seen before. So a sub n is n factorial, and that is 1 factorial, 2 factorial, 3 factorial, comma, dot, dot, dot. And that turns out to be 1, 2 times 1, 3 times 2 times 1, 4 times 3 times 2 times 1, right, etc. So I can see I get 1, 2, 6, 24, dot, dot, dot. So the factorial, it's not like I'm going 2. I'm not excited about saying 2, right? It's not 2 exclamation point. It's 2 factorial. And it's just multiplied by all of the positive integers, right, in decreasing order. So, for example, 5 factorial is 5 times 4 times 3 times 2 times 1. And it's actually times 0 factorial with 0 factorial always equal 1. And this is a little bit of a strange concept, but so since 0 factorial is equal to 1, I didn't even include it in my notation up here. Right? I just said 2 factorial is 2 times 1, and that's 2. But it always does include 0 factorial, but it's just a little side note. So that factorial one's a tough one to see sometimes, especially if you just have denominators of 1, 2, and 6 and 24. It's hard to see that. What's interesting in this is when I start talking about sequences. Okay, so these are my when I start talking about series, I'm talking about adding up these terms, right? So when I start talking about the series, I'm talking about the sum of I equals 1, let's say, to infinity of 1 over 2 to the n, right? So let's start writing out terms here. And the difference is, by the way, this symbol is a capital letter S in the Greek alphabet, and it's called sigma, right? Sigma. But for us, it's a sum. So we're not just listing the numbers now, we're going to be adding the numbers. So what's my first number here? It's 1 over 2 to the 1. And you can see, how am I writing this? I'm writing it so simple as I can, and then I'll try and put in the other pieces. So then I want to say plus 1 over 2 squared, right? Plus 1 over 2 cubed, plus dot, 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 forever, right? And so this, now I can write it as 1 over 2 plus 1 over 4 plus 1 over 8 plus dot, dot, dot. Now it's pretty easy for me to see what's coming next, right? What's coming next is 2 to the 4th, right? Which is 16, right? I can see that I'm just multiplying my denominator by 2 every time I'm doing this, right? So what's the difference between sequences and series? When I'm talking about the series, I'm adding up the terms. When I'm talking about a sequence, I'm just listing the terms, right? This one turns out to be geometric, right? So this particular series is geometric. Just a quick side note, geometric series is a sub n equals r times a sub 1 times r to the n minus 1, and our arithmetic series is a sub n equals a sub 1 plus n minus 1 times d. So first of all, what's the main operation in an arithmetic series? Looking at this looking at my general formula here. What's the main operation in my arithmetic series? Well, better yet, what's it in the geometric series? What am I doing with these two terms, a sub 1 and r? What am I doing with those?
A sub 1 is the first term.
Yeah, a sub 1 is the first term in both. Yeah. But what am I doing with in the first series? What's the main operation I'm doing? Mathematical. Multiplying. And in arithmetic, right, we already saw that we were just adding the same thing, right? So R is a common ratio, right? And D is the common difference. So this particular series is a geometric series. I'm multiplying by 1/2 every time. So when I'm multiplying by the same thing every time, it's called geometric. Okay, and we use those for certain things in Calc 2. The ones we're going to deal mostly are these arithmetic series, and here we're adding the same thing every time, or subtracting two consecutive terms and we get the same number every time, right? Subtracting two things and we get the same number every time. So this is another way to use my arithmetic series to find my nth term with an arithmetic. Right? We can do another one like that real quick. So if I gave you 7, 4, 1, what comes next? Could you tell me? Can you see the pattern?
Oh, they subtract 3.
Yes. Who else said that? Someone else said that too, besides Ryan. Elise?
Yeah.
Nice. Yes. So -2, right, is our next. Can anybody else see that now? -2 is next. What about the next one?
-5.
-5, yeah. So what am I adding every time is a -3, right? I'm adding a -3 every time, right? So I know my a sub n here is the first term, 7, right? Plus n minus 1 times that -3. Well, it makes a little bit more sense for me to write it like this, right? And then, of course, I could distribute this, right? I could simplify this. I get a 7 minus 3n plus 3. So it looks like I get 10 minus 3n. So there's my nth term. That's a nice way to write the nth term there. So when it's arithmetic, we're talking about it being an mx plus b, right? Pretty simple there. So there's two ways, right? There's two ways that you can get that arithmetic sequence now. You could list it like points on a line, right? Or you could use this particular formula here, right? Manish, you got a question there? Manish, question? No? I saw your light go on for a second. I thought you were going to ask something.
No.
Okay. So by the way, on every test that you're going to be taking, you're going to be allowed. I mean, I can't stop you from doing this, so I just will make it official. I'll give you one page front and back that you can write anything you want on, right? So one page front and back that you can have there while you're taking a test. I know sometimes I don't think anything we do is difficult to do. I think remembering what to do is difficult, right? And so that one page of notes, and don't tell anybody. Don't tell anyone I'm doing that, because I'll get fired, or at least wait till the semester's over and then you can get me fired if you want. Remembering what to do is difficult. And then if you have test anxiety, and anybody get nervous on tests and forget things or blank out, or right? Anybody here?
Yeah.
Yeah. So this. Yep. So you'll come alive when I ask you if you get nervous on tests. But if I ask you for the nth term, forget it, right? So yeah, so you'll have one page of notes. So obviously this arithmetic sequence formula is going to go on there, right? Jarrett, question.
Oh no, I was saying the testing that.
Oh, I got you. Yeah. Yeah, there's two, like, there's a place where you can give a thumbs up, or there's a place where you could raise your hand. And if you raise your hand, you get moved to the top of my screen, and then I know that that I call on you. And I don't that's great. You can do that in time. You can just like if we were in a class, I would just expect you to just yell it out loud, kind of thing. Yeah. And like Ryan's been answering a lot. If I ask a question and I don't, oh, there's my dog. If I don't want Ryan to answer, I'll say, Ryan, everyone except you. Let me see what's going on with my dog. Lucy. Come say hi to the class. Come on. Come on. Come. Come over and say hi to the class. Come here. Oh, she just laid down. Let's see if I get her. Lucy. Here she is. She's got a tuxedo on. Okay, where was I? Oh, so arithmetic sequence is, right? Nth term, finding an nth term, writing out terms. And then now we're starting to talk about sums. Let me look at an interesting sum first of all, okay? So, and this is, I'm a nerd, so this is what I would call an interesting sum. This is the number E, right? So what is E on our calculator? It's approximately 2.71828. And there is, it looks like there might be a pattern here. 1828, but there's not. 1828, 1828, and it goes on forever, right? And so this thing is called a irrational number, right? But there's no pattern. It never ends, never repeats. Have you seen this number before? Have you seen this number before? Pi? Right.
Yeah.
Pi is approximately what? So pi is approximately 314159264. Forever and ever, no pattern, never repeats. So pi is a special number to geometry, right? Related to what? Circles. And E is a special number related to money, interest. So if you ever had some financial math, you would have seen this thing coming up. But for me, it's something that we'll talk about in Calc 2, that E is the sum of 1 and the sum of, from n equals 1 to infinity, of 1 over n factorial. So that's pretty crazy, right? But if we can start to write out some terms here, right? So this is 1 plus, what would be my first term here? And how would you, so not Ryan. How about Aiden? How would I write the first term? Or can you tell me the first term? I don't know if Aiden's there. How about Benjamin C., Benjamin Cortez? Oh, I know Sarah's here. Hi, Sarah. What would I write? What would be my first term in that sum?
I'm not sure. I'm having a little trouble understanding.
Okay, so how do I start this, right? How do I start this? I just start by writing 1 over what? What's my first index always? Anybody? What's my first index?
One.
First
One.
index
One.
is 1.
Always.
Scalar.
Yeah, so 1 factorial. Plus 1 over, what's my second index?
2.
2 factorial. See, it's that easy, right? I promise you it's that easy. Start writing it out first. Don't do the math for it yet. Plus 1 over 3 factorial, plus a whole bunch of more, right? So what do I have there now? I have 1 plus, 1 factorial is 1, right? 2 factorial is 2, right? 2 times 1. 3 factorial is 6, yes? 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1, so 24, plus etc. Let me just go to my calculator on that, right? So I'm just going right there. So E is approximately 1 plus 1 plus 1 over 2 plus 1 over 6 plus 1 over 24. Everybody following me? 2.70383 repeating. So look at that, right? Look at my actual E, 2.7 what? 2.71, right? Look at this. This is really close to 2.71, isn't it? With just 4 terms of that series. So pretty interesting. How we doing here? Is anybody okay? Am I scaring everybody?
When you put that into the calculator,
Mhm.
do you put the fractions in parentheses?
I actually just typed 1 plus 1 plus 1 dash 2 plus 1 dash 6, right? I just type like that.
Okay.
Yeah. See if you make sure you get there. There is a factorial button on your calculator, by the way. Here's my calculator. It's a little bit difficult to see this thing. But like so, I'll type 3. I'll go to math, over to probability, down to factorial, and hit enter. So I've got 3 factorial. So there it is, 6. 3 times 2 times 1. Right? Again, 4, math, over to the probability functions, down to exclamation point, and 4 factorials. 4 times 3 times 2 times 1, 24.
Nice. Thank you.
Yep, you got it. So you can, so my other class, some students already bought calculators. I'd really not like you to have to spend money, so you can get a calculator if you're near Tacoma Park. It's the Science Learning Center, which is right across from the Math Learning Center, right? And if you're in Rockville, it's the Math, I think it's called the Math Center. It's right set. I don't know where it is in Germantown, but if you just search for calculator loans on the school website, it's usually at the learning centers, I've found. All right, so we have a couple of special series that we want to remember. We're going to put on our formula sheet, right, when we take the test, and we're going to use these special series. So let me just write a new page here, and we're talking about special series. Well, obviously that E is a special one, right? But that's not really going to come in play for us until Calc 2. But there are a few here that will come in play for us. The first is the series of I equals 1 to n of a constant. So this is c plus c plus c plus dot 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 n times. And what I get as an answer is n times c. So if I add up 5 7 times, right? 5 plus 5 plus 5, 7 times, I get 35, 7 times 5. So that one doesn't need much proof. That one's pretty obvious, right? The sum of I equals 1 to 3 of 7 is 7 plus 7 plus 7, right? Yeah, you get me? So the first term is 7, the second term is 7, the third term is 7. And how many terms do I want? The top number tells me three of them, right? And so that's 21 if I just add them up, but of course that's 3 times 7, right? So that formula obviously works for the sum of a constant. How are we doing here? We comfortable?
Yeah.
The next one, and I'll give a nice summary of these in a second. The next one is the sum of I equals 1 to n of I. So we're adding up the indices. What's the first index again? What do I start?
1.
1. Okay, so 1. What's my second index?
2.
2. Oh, so I'm just adding up all of the numbers. 1 plus 2 plus 3 plus, I'm adding up the indices, right? Plus dot, dot, dot. In fact, my last number is n. And what do I get? I get n times m plus 1 all over 2. What? That's crazy. You're kidding me. No, it's true. And this one I'm gonna prove to you today. So we've got 4 of them that we're going to use. Okay, this is the first 2, but let me at least show you an example with this one. Okay. So the sum from I equals 1 to 5 of I is 1 plus 2 plus 3 plus 4 plus 5. So I'm supposed to stop at the 5th term, right? It tells me where to stop. That top number tells me where to stop, right? The bottom number tells me where to start. The top number tells me where to stop, right? So I can add these up pretty quickly, right? What do I get? 9, 12, 14, 15, correct? Everybody okay with that? 1 plus 2 plus 3 plus 4 plus 5? Yes?
Yes.
Nice.
Yeah.
Good, but let's see if my formula works. So what was n, right? I had n is 5. So 5 times 5 plus 1 all over 2. That's 5 times 6 all over 2. That's 30 over 2. Guess what? That's 15. Huh. So the formula worked, right? The formula worked. So there are some homeworks like this. This is kind of simple, and we'll open up that homework and do a couple of the problems very soon, okay? But on this particular one here, I want to prove this, okay? This is the Gauss proof. Gauss. He said, well, and I think he's like 8 years old at this point when he did this. Friedrich Gauss, some German cat, right? So let's see, 1 plus 2 plus 3 plus dot, dot, dot. But I want to, at the end, I want to add n, but I want to go one term earlier. How would I write one term earlier? Like if I ended at 10, what would be the term right before it?
N minus 1.
Yeah, n minus 1, or not, right, I would be thinking like 9. And then what about the term right before that, n minus 2? Is that okay? Everyone agree with that? And you can figure this backward. Like if I said n was, right, if I said n was 10, then 10 minus 1 is 9, and 10 minus 2 is 8. Oh yeah, it makes sense, right? Yes, you with me there?
Yep.
Nice. So Gauss said, well, let me write the sum again, but I'm going to write it in reverse order. So I'm going to add n. I'm going to add n minus 1 I'm going to add n minus 2 plus dot 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 plus 3 plus 2 plus 1. And I'm going to add these two lines up. So on the left, I'm going to add the sum plus the sum, which is 2 times the sum. Right? 2 times s, that's a weird s, Robert. And then what do I get here? N plus 1, right? And what do I get here? N plus 1, again. In fact, every one is going to give me an n plus 1, right? Every one I circle is going to, every time I take any of these sums, I'm going to get an n plus 1, right? So I'm going to get an n plus 1 how many times? N times.
N times.
So I get 2s equals n times n plus 1. And if I divide by 2, I get the sum is n times n plus 1 all over 2. And there's the proof by an 8-year-old German kid. I don't know what year, 16 something, I don't know. When was Gauss alive? I don't care. So pretty fascinating that this sum works out. Now, let's take a quick look at a homework problem. Okay, so I think this is like I have it open. Let me open it and see if it's still open. Oh, good, it's still open. So just to show it here, and then I'll write it on paper. Right, so they want you the nth term on this one, right? We did a bunch of those, so this one is the one I want to do. It says write out the first term, the second term, and the last term of this sum, right? And so they'll use different letters all the time. K, J, I. This is homework 1. Number, don't tell me. And when you open the homework, you could have different, your problems could be different. So don't freak about that. And it's also why I don't want you, when you're asking homework questions, I don't want you just say do homework 1 number 5, because it's going to be different for everybody. So right, you're going to be taking a photo of the problem, a photo of your work, and putting it all in an email where I don't have to click on anything, right? I can see the question in your work without, right? So this is the k equals 1 to n of k plus 5. The sum, I forgot which number. K equals 1 to 5 of k plus, sorry, is that right? K equals 1 to, sorry. Okay, it's homework 1, question 6. 1 to n of k plus 5, sorry. Right, and so they want the first term, the second term, and the last term. Right, first term, second term, last term. So what's the value for k in the first term?
6.
6.
I like 1 better. I like the answer of 1, right? Because I want to do something as simple as possible. So I really am just writing 1 plus 5 here. And then in the second term, what's the value of k?
2.
2. So 2 plus 5. Right? And remember, this is, I'm trying not to think too much, right? Walking to California is difficult, but every step is not difficult. So I'm trying to take 1 step at a time. What about the last value for k?
N plus 5.
Yes, so n plus 5. And then, so I believe WebAssign would accept this. Of course, we're going to rather write it as 6 plus 7 plus n plus 5, something like that, right? Dot, dot, dot. So, but the idea is fill in the indices first, right? And then simplify if you can. right? So this particular one is quite interesting. If I say I want the sum from k equals 1 to, let's say, 4 of k plus 5, okay? Because I have formulas for the sum of k and the sum of 5. And it should be pretty easy to see that this is the sum of k plus the sum of 5. Right? If I'm adding things up that are being added, right? Think about it. So remember, the sigma means add. But then I've got the k and the 5 and I'm adding them. So I can add the k and the 5 and then add them all together. Or I can add up all the k's and then add up all the 5's and add them together, right? That makes sense? Kind of like a distributive property here. Do you see that? Anybody with me today?
Yeah.
Thank you.
Yeah.
Thank you. So, and of course we know our value of n, right? What's our n value of n?
4.
Yep, for n equals 4. But I have a formula for the sum of k. That is n times n plus 1 all over 2. And I have a formula for the sum of 5. That's 5 times n, right? And I'm going to plug in the 4. So what do I get, right? I get 4 times 4 plus 1 all over 2 plus 5 times 4. So what do I get? I get, help me, 4 times 5 over 2 plus 20. I get 10 plus 20, I get 30, right? Now let's go back to what we had done before. Right? What did we say before? We got the first term, it was 6, and we got the next term, it was 7. Can you tell me what the third term is? 8, right? So if I want 4 of the terms, right, I need to add up 6 plus 7 plus 8 plus, 9, right? Yes, you with me? Remember, I had done them up here, right? The first term was 6, second term is 7. I can see the next term already, 8 and then 9. And of course, what do these add up to? Well, it's 13 and 17. Guess what? It's 30, right? So these special series allow me to do these sums a lot quicker than adding up term by term. I could just jump to the last term. Okay, I said I have 4 special series. Let me write them all on one page, okay? So we're talking about the 4 special series here. The sum of a constant, right, from I equals 1 to n is n times that constant. The sum of from the first index to the last index of index I, so add up the numbers, right, is n times n plus 1 all over 2. The sum of I equals 1 to n of I squared. Now the indices squared, right? And so that's what 1 squared plus 2 squared plus 3 squared plus ... right? That's what 1 plus 4 plus 9 plus ... right? That one is n times n plus 1 times 2n plus 1 all over 6. And the last one that I'm expecting you to know is the indice cubed, and that is n squared times n plus 1 squared over 4. Okay. You can kind of see where we're going here. Do you see? Anybody see it? Where am I going with this? Why do you think I'm doing this? To torture me. I'm going to take attendance real quick, okay? So if you don't want your to be on my phone for the next 5 minutes until so after class ends, I'll go and take a picture of the class and then take attendance and then delete the photo. So because I don't have memory. I'd rather have music on my phone than attendance photos. 4, 8, 12, 16, 19, 21. We're missing 2 students today. Oh boy. So where are we going here? What's your instinct say?
The exponents are increasing by 1.
Yeah. So what are we talking about in algebra?
To infinity.
Say it again, Manish.
To infinity.
Yes. Yes. Yvonne, you said right, but what algebra thing has exponents like that?
Polynomials.
Polynomials, exactly. So, in calculus, we're going to take some polynomial, right? Some p of x, and we're going to, let's say, from one number to another, and we're going to get the area under the curve by doing the integral from a to b of p of x. Okay, and this is the area under the curve. And so this has got special properties in calculus. The area under the curve tells us certain things. And the way we do that is we can estimate it by summing up rectangles. So it's equal to the sum of p of x. And so we're adding up the heights of polynomials to get area under the curve in calculus. And so that's why we need this. That's what we're working on, all of this for you, right? So like p of x could be like x squared plus 4, right? It's a polynomial. And so now I can do sums like that. Let's take a look at the homework problem. So I think I try to keep it to 10. There's some with less. There's maybe 1 or 2 homeworks with more. But I try and not make it too long. And Cindy, is this, I mean, so they're going to ask me for this sum, right? And so they're just asking for a single number here, right? But like if we looked at problem 1, let me go back and see. Here's the math palette, right? Do you see that down here? So like if I needed to type a square root, I could just put the square root symbol there and then type in it, and so that type of thing. And the keyboard will work too. So backspace will delete it, right? If I wanted to write like 4 squared, I can use the caret symbol, and that would give me an exponent, right? That type of thing. I think fraction, I can do divide on the calculator. Yep, 5 divided by 4. So there's a fraction on there. So I think you'll get used to it as you start to do it. What's this sum? Well, this is the sum of how many numbers?
49.
49. So I can add up 1 plus 2 plus 3 plus 4 all the way up to 49, or I can use my formula. Of course, I'd rather use my formula, right? Because I'm lazy. So the sum of k equals 1 to 49 of k, right? And so, MC alert. Why do we get this? They're talking about hazardous weather coming in at 1:30. So they're closing the college. Does anybody have class after today, after our class, or tonight?
But it's all online.
Right. So it would only be face to face. Yeah. Right. There's no more snow days for us ever again. Tomorrow school is closed, but we will meet remotely. So this is what 49 times. oh, this is sorry, n times n plus 1, right? I have a formula for this, right? It's n times n plus 1 all over 2, and my n value is 49, right? So 49 times 49 plus 1 all over 2. So that is 49 times 50 all over 2, or better yet, 49 times 25. Don't do it, I'll do it. Don't bother yourself. I got a 1225. Anybody get the same? So pretty easy, huh? Pretty easy. This homework should be pretty easy for you. I guess to get a little bit more complicated, we'll try and do one more here. I'm almost out of time. Let's see if there's one that's even better. This is question 10. That's about as complicated as they get, I guess. So question 10. There are more problems in the book, right? And you'll do the examples in the book. From 1 to 4 of k cubed minus 2. Let me do a different one, right? Let me do a different one. The sum, let's do the sum of I equals 1 to 5 of, k squared, I squared, I squared plus 5i plus 3. So x squared plus 5x plus 3, right? Quadratic. So this one I can split into 3 sums, right? You with me? The sum of I squared, the sum of 5i, and the sum of 3. I get a little bit lazy with the subscripts. I know each one goes from 1 to 5, and I know my final value of n is 5, right? So I'm kind of cheating that a little bit. So I have a formula for I squared. That's n times n plus 1 times 2n plus 1 all over 6. I have a formula for the sum of I. So this is really 5 times the sum of I plus the sum of 3. Right? So what's my formula for I? It's n times n plus 1 all over 2. And what's the sum of 3? It's 3n. So I've got n times n plus 1 times 2n plus 1 all over 6 plus 5 times n plus 1 all over 2 plus 3n, right? So I've taken each of these sums, I've taken each of these sums, right, and replaced them with my formula, right, for that particular series, right? The green part is the sum of I, the blue part is the sum of 3, right? The sum of 3 is 3n. Sum of a constant is n times the constant, right? Is that making sense? Everybody with me there?
Yeah.
So then I'm plugging in, and what's my final value for n? It's 5, right? My final value for n is 5. So I'm plugging in 5 times 5 plus 1 times 2 times 5 plus 1 all over 6 plus 5 times 5 times 5 plus 1 all over 2 plus 3 times 5. And now we're just racing. 5 times 6 times 11 over 6. This is 25 times 6 over 2 plus 15. You know, at any point I can go to my calculator here, right? So 90, so 145. You know, I do my arithmetic fast, and you don't have to do your arithmetic as fast as I do it. I just get bored, so I go fast, and I'll make mistakes. But we want to work fast, but not make mistakes, right? Do as I say, not as I do. But anybody get the same answer? Nice, thank you, Ryan. So homework 1 is all set for you. You're all ready to go. Next class I'll have the video posted, but you know where to find it anyway. If someone is asking about in the group me, you know, what do we do today? but I'll show that where that video is again next class, and I'll put the link up there as well. Okay. Good. Any questions for me? Anybody a little frightened by this? You're awfully quiet. It sounds like I think I can sense some fear going on. But hopefully I wasn't going too fast for you. It's just new. I think that's the thing that's new for a lot of you. And it really starts with you just starting to write out terms. Real simple.
Yeah, it's new.
Yeah, new. It's different, right? And it's different. It's weird notation, and yeah, I get it. You'll be fine though. Remember, I'm trying to make you into excellent calculus students. I have to torture you a little bit here.
Sir,
Yes.
Professor,
Sorry.
is
Yeah.
are Venn diagrams also part of this this course?
No,
Oh, right.
that would be more of a probability statistic.
Because
application.
I've done sequences and sets in the past, and Venn diagrams was an integral part of the chapter that I did, but that could have just been my board in my school at the time.
Yes,
so
yes. And where was that school?
It was back when I was in India.
Yeah. So different system, but yes, I can connect the Venn diagrams to it, but it's we don't need it for the calc. Okay. So I'll stick around if you have questions or you want to talk to me, but otherwise we're done, and I will see you all Friday at noon. Okay. Be careful tonight. Weather's going to be bad.
Thank you.
Okay.
Thank you, Professor.
Thank you.
Thank you.
Bye bye.
Thank you.
Thank you.
You're welcome.
Where can I see when the dates for the